try to give you partial credit. I try to be fair. I try to understand where you're coming from. It's the end of the day. And so rather than just saying either you got it right or wrong, I'm giving you partial credit. So I look at the problem and I think, okay, what are the key things that I'm looking for? So this first problem, you needed to solve it. You needed to graph it. And in graphing it, in particular, I was looking for if you had opened or closed circles. Okay, so that's how that counted as a three-pointer. Okay, so in this particular case, I know that 3t, I move my 4 over, and 3t is going to be greater than 6.
Do you have to switch the sign when you divide it, though?
When is the only time that I switch the sign?
Negative.
Positive or it has to only by a negative number. Okay, so that's the only time that I switch the sign. Okay, so for problem number 2, you really had 2 problems there to solve. Yes? Okay, there is one on the over here, negative 3x is greater than or equal to 9, or, so I counted it as a 6-pointer. 3 points for doing this one correct, 3 points for doing that one correct. So if you made an error in that, and again, it's dividing. Here I had to divide by a negative 3, so this is when the signs would switch, Emily. Okay? And in this case, I subtracted the 3, and I had x is going to be greater than 1. I had an open circle. Some of you are forgetting that. It's about an open and a closed circle. Okay? Number 3 is write an inequality for the graph. I counted that as 2 points. Thought that you needed to look at it. You needed to understand that it was going to be less than or equal. How do I know that it's an equal? It's a closed circle. Okay, and remember, we talked about if it is included, okay, it's included because it has the equal to, included has a solid circle, and if it is just a symbol like this, it is not included, it is an open circle. Okay? All right. We had a discussion on 4. Number 5, I think everybody was okay. The absolute value of a negative 24, positive 24. Pardon me? Okay. Number 6. Solve, let me see, what did we have to do? We had to solve this. How many times do I need to solve an absolute value problem? An equation. Twice. I solve it once as a positive and once as a negative. So I'm setting this problem up as 4x plus 3 is equal to 5, or 4x plus 3 equals a negative 5. I set it up twice, I solve it twice, and since it's an equal, what happens? That's it. It's just those points. It's not greater than or less than or whatever. Okay? All right. We skipped 7. Number 8. All right. Some of you made some mistakes here on this. Remember, and I think I showed you on your paper, first of all, is the slope positive or negative? Negative. Whenever you're looking at a graph, you're always thinking, is it positive or negative? That's a common trap. A lot of people make that mistake. It's a negative. So the first thing I do when I write my equation down is, oh, it's a negative. So I know that it's going to be negative. I know that it's crossing the y-intercept at a negative 1. So I write that in. You can see that there's a big space there. I then go back to figure out the slope. And in this case, it was pretty easy. And this 1 represents the what? The rise over, or the fall in this case, is the y-axis. So it's 1 over 2. Somebody put 2 over 1, and it's 1 over 2. Okay? And since it's a solid line, does that mean that any point on the line is a possibility, possible solution? Yeah.
Yes.
Okay. The next one is, again, it's a positive slope. For me, I looked, oh, it's a dotted line. I I see it shaded. I put my symbols in right away. I thought, okay, where does it cross the y-axis? It crosses right here at 2. And then the last thing I do, at least when I solve these, is I look for the slope. But it's it's attention to detail. And in this case, it was my rise is up 3 over 2, and I know that that was my slope. Okay, so that should be pretty straightforward. Okay, let's talk about the traps.
I think what screwed me up was that there weren't any normal absolute value inequality problems. So I figured one of them had to be, and then I didn't even look for it.
Yeah, I did not.
Oh, that's how. Well, that's test taking
traps are
strategy, huh?
Which really messed me up.
Which really messed you up. You were thinking one of them had to be. Okay. Can anything that comes out of the absolute value box be less than -2? No. Okay? So I want you to know, I made this test up, I gave it to you, I corrected it, and I asked 2 other math teachers in the math department, is this a fair, are these fair questions?
Who?
I'm not telling you who.
I expect all 3 of them to be trapped.
Yes, Mr. Kelly.
I did ask Mr. Kelly, he was one of them,
Strong.
and Mr. Kelly
Kevin Kelly.
Mr. Kelly said, absolutely, they need to learn how to think.
Kevin is from Egypt.
And what happens is, oftentimes, and I have to say, I made the test up, okay? I made the test up. And I fell into the trap on the second problem. And I'll show you my
You
work.
wanted us to fail?
Okay, so I'm merrily going along, and I'm thinking, wait a minute, that doesn't make sense. And that's what you need to learn how to do. So I started thinking, if I put any value greater than a -5, which would be what, a -4? So I plugged in a -4. A -4 plus 3 is what, a -1. Is -1 going to be greater than -2? Yeah, because it comes out of the absolute value. And then I thought, how about -6, which would prove this statement incorrect, because it's less than that. So if I put a -6 in there, and then I realized, wait a minute, any number that I could possibly think of. So what does that tell you? It's all real numbers. Yes?
So if you are, if it's every single number, why are you still able to solve it for certain ones?
It has to do when we will get into graphing these and looking at things. And so actually, let's take out a graphing calculator right now and check that out. You would think it would not work, but I'm sorry. All right, so I'm going to clear there. So let's graph x. I want the values of x plus 3 greater than a -2. So everybody remember math? Number, absolute value, and I'm putting in what, x plus 3. Oops, I hit the wrong button here.
Like, how do you start?
I went to math, I went to y equals, I went to math, I scrolled over, I hit number 1, enter, so I have my absolute value, and I have, what, x plus 3? I'm closing it, and then it's what, -2, right?
Well, it's less than that.
Okay, I'm not doing the symbol, I'm just, oh, you're right, I've got to clear that.
How do you do the
Delete.
symbol?
I'm going to go with delete. Delete. Okay, so let's go to y equals -2. We're gonna just enter in a -2. Okay? And let's graph what we have here.
Okay.
Look at all the values that I plug in that would be less than -2.
X plus 3.
I got 2 lines.
You should. because that is our y value in this case is the -2, and this is the absolute value. So all the numbers that I plug in are possible solutions, and they are, is that, hold on a second, less than -2.
Why don't they shade on the calculators?
No, I can't shade this. Well, I can, not with the -2 though. Not shading in that equation.
Yeah,
You can, I'm not sure.
Yeah, mine's shaded.
You go over to y and you go, where is it?
Okay, hold on a second, maybe.
It's the slash, and you just hit it until it,
So this will be
hit enter.
greater than, I think this is less than. Let's see, so that's it.
You didn't put in your -2.
Oh, there it is. Yes,
How'd
it
you do
is.
that? How'd you do it?
Oh, mine's
Whoa,
backwards.
whoa.
How'd you do
Okay,
that?
I'll show you how to do that.
Wait,
All right. I'm not sure if I did that right time. Yeah, I
Kinda
think
makes
it's
it
the
hard
other
to
way
see,
around.
though.
Okay, so go back to y equals, and I'm moving my cursor over to this right here. Okay, everybody there on that cursor, and I'm hitting enter. So if you look at it, whoops, it's 0.
Oh,
There's
cool.
a straight dotted line. Here's my original. I'm entering the enter sign. And this would be that this is, you see how this is greater? This